Hello and welcome to Mr. Kennedy's MathsCast. Today we're looking at the nth term. We're going to be looking at how to find the nth term if you've got the terms of your sequence, and how to find the terms of your sequence if you know the nth. Let's start off by looking at an example. Here are the terms of our sequence. The terms are just the numbers in the sequence. Above in yellow we've got the positions, the term in the first position, the second position, the third position, etc. The point of the nth term is it gives us a rule to go from the position in the sequence to the term in the sequence. Let's start by looking at the difference. We can see that between each pair of consecutive terms in this sequence we're adding 3. That means it's a little bit like the 3 times table. We know it's not exactly the same as the 3 times table, so let's have a look, let's compare. Here we've got the positions in my sequence. Let's look at what the 3 times table would look like. So here it goes up in 3s, and to get from the position to the term in our 3 times table, all that's happening each time is we times by 3. So I times 3 by 3 to get 9, I times 4 by 3 to get 12, 5 by 3 I get 15, which means for my nth term, that's for any position in my sequence, I would times that by 3. But our sequence isn't quite the same. Let's have a look at our sequence now. Okay, so we can see that it goes 4, 7, 10, 13, 16, and carries on like that, adding on 3. What's the difference between our sequence and the 3 times table? Let's have a look. Well, each time our sequence is just 1 bigger than the 3 times table. We've taken each number from the 3 times table and added 1 to it. So that means that if we take our rule from the 3 times table, this 3n rule down here, if we add 1 to that, that gives us the rule to our sequence, 3n plus 1. Now let's look at another example. We're going to start again by looking at the difference between each pair of terms. This time it's going up in 4s, so that must mean that it's related to the 4 times table. Let's look at the 4 times table on a number line. Here's my number line, and these numbers here are the 4 times table, but these again aren't the numbers of my sequence. These numbers, they would have the nth term rule of 4n. And like I said, these aren't the numbers that we want. We want the numbers from our sequence, which if we have a look at these blue circles, are just one space to the left of the 4 times table. One space to the left means that each number has had 1 subtracted from it. So this sequence is 4n take away 1. We've taken the 4 times table and shifted it back by 1 space. Now, why is this nth term useful? Why can't we just keep on adding and adding and adding to find the terms that we want to use? Suppose we had a question like this one. We've got a sequence here, and the first question says, what is the 6th term? We've got the first 5 terms here. We can a quick check will tell me that it's going up in 7. I'm adding 7 for the next one, adding 7 and adding 7. It looks like we're just going up in 7s here. So to get to the 6th term, I'm just going to add on 7 again. That's going to give me 44. Pretty easy so far. Next, ask what's the 10th term. A little bit tricky. We're going to add on a few more 7s. So I'm going to have 51, 58, 65. I'll get to 72. It was a little bit tougher, but you can get there fairly easily. And now the next question. What's the 102nd term? If I'm going to keep on adding 7s here, I'm going to be here for quite a while until I get to the 102nd term. So I think we're going to have to look at this in a different way. So here's my sequence. Let's start again by looking at the difference. Well, it goes up in 7s, so that must mean it's related to the 7 times table. But this sequence starts at 9. I know that my 7 times table normally starts at 7. So this must have been shifted by 2. Since it's related to the 7 times table, I know that it's going to start with a 7n, and since it's been shifted up by 2, I know it's going to have a plus 2 at the end as well. So that must mean that my nth term rule for this sequence is 7n plus 2. Now let's take that rule. We want to find out what the 102nd term is. All I need to be able to do in order to find that term is I need to say, well, let's have n equal 102. Now that n is equal to 102, I just need to substitute that into my nth term rule, into 7n plus 2. So I'm going to have to do 7 times 102 then I add 2 onto the end. 7 times 102, that's 714. 714 plus 2, not so tricky, that's going to be 716. That would have taken me a long time, adding on 102 sevens to my 37. This is a much quicker way of doing it. Okay, let's look at an example GCSE question now. This is taken from a past paper of a GCSE exam. The nth term of a sequence is 7n minus 4. Write down the fourth term. Well, this is like what we've just done, isn't it? We just need to say n is equal to 4. So I'm going to have to do 7 times 4, which is 28. Then I'll subtract 4 from that. 24 will be my answer for that first part. The next part asks me to write down the 10th term. So this time, I'm just going to say that n equals 10. I'm going to do 7 times 10, which will give me 70. Take away that 4, which it says to do in the rule, and I've got 66. So 66 must be the 10th term of my sequence, which is described by 7n minus 4. In part B, the first 4 terms of a different sequence are 9, 13, 17, and 21. They want us to find an expression for the nth term of the sequence. Okay, so we're going to have to start again by looking at what the difference between each of those terms is. Let's have a look here. So it's going up in 4, going up in 4, going up in 4. That must mean it's related to the 4 times table then, right? That means that my rule is going to start with a 4n. But that's not quite right, because my 4 times table always starts at 4. This sequence starts at 9, which means my 4 times table has been shifted up by 5. If it's been shifted up by 5, that means I'm adding 5 to every single term, so my rule is going to be 4n plus 5. There we go, we've got all the marks for that question. Grade C at GCSE for getting those right. Thank you for watching Mr. Kennedy's MathsCast on the nth term rule. In a bit.